Hello and welcome. In this video, we are going to be going over the structure of an atom, and then we will talk about covalent, ionic, and hydrogen bonding. Let's start off with matter. What is matter? So matter is anything that has a mass and it occupies space. And that pretty much includes everything. So it could include things that you can see, things that you cannot see. So air is something you cannot see, but it has mass and it occupies space. So it is considered matter. Your pen, your shoes, your book bag, your clothes, they're all made out of matter. Matter is composed of elements. Elements are the stuff that is found in the periodic table. So for example, nitrogen, oxygen, carbon, fluorine, sulfur, etc., all those are elements. If you try and break down an element, let's say you have nitrogen, and you try to break it down to the tiniest piece you can possibly get to, you would get to an atom of nitrogen. Atoms have a particular structure that we're going to talk about next. So atoms are made out of three subatomic particles. Those are protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, they have no charge, and electrons are negatively charged. Let's take the example of carbon. So if we go to the periodic table and we look at carbon right here, we're going to see that carbon is, it says C here, and then 12 on the top, 6 on the top and 12 on the bottom. So the number on the top, or I should say the smaller of the two number is the atomic number, and the larger of the two number, it's going to be the mass number. It's always that way. The smaller number will be the atomic number and the larger number will be the mass number. And some periodic tables will have the atomic number on the top, like this one does, and some will have the atomic number on the bottom. Regardless, the smaller number is the atomic number. So what is the atomic number? The atomic number tells you the number of protons that particular atom has. And mass number tells you the number of protons plus neutrons. So in the case of carbon, let's find out how many protons and neutrons it has. So carbon has 6 protons, 6 neutrons. How do we know it has 6 neutrons? Because we know that the mass number is 12. We know that the number of protons are 6. And so by simple math, we find out that the number of neutrons is also 6. The number of electrons will be the same as the number of protons. So number of protons is 6. The number of electrons will also be 6. So let's go back, and now we're going to draw the structure of a carbon atom. It has 6 protons, it has 6 neutrons, and it has 6 electrons. The middle of an atom is the nucleus, and the nucleus holds all the protons and neutrons. So in this case, you have 6 protons and 6 neutrons. Outside the nucleus, you have shells or orbitals. And this is where electrons are found. The first shell can only hold up to 2 electrons. Now remember that carbon has 6 electrons. We placed 2 of them. The other 4 we're going to place on the outside, on the second shell. The last shell that an atom has is called the valence shell. And the number of electrons in that shell are called the valence electrons. And in this case, carbon has 6 valence electrons. What all atoms want is to have 8 valence electrons. Okay? They want, or I should say all atoms want 8 valence electrons in their outermost shell, in their valence shell. whether we're talking about sodium or carbon or chlorine, um, they all want 8 valence electrons. Hydrogen and helium, however, don't. So if you go to hydrogen, which is right here, if you can notice, the atomic number is 1, which means it has 1 proton. And helium is here. Helium has 2 protons. Hydrogen has 1 proton. One proton, 1 neutron, and 1 electron. If I draw the structure, I'm going to have 1 proton, 1 neutron in the nucleus, and then I'm going to have 1 shell only. The first shell. Remember, I said that the first shell can hold only up to 2 electrons. So what hydrogen wants is to have 2 electrons in its valence shell, which is its only shell, and that will make it happy. Helium has 2 valence electrons. It has 2 electrons in its first shell, and so helium is happy. In fact, if you look at all of these elements, they all have a complete valence shell. Their outermost shell is filled up. So helium's outermost shell, which is its first shell, has 2 electrons. It's filled up. Neon, argon, and the rest of them, their valence shell will have 8 electrons. These are called inert gases. And they're called inert gases because they don't react. Their octet is complete. Their valence shell is completely filled with 8 electrons, or 2 in the case of helium. And so they have no need to react with any other atom. Now, let's come back to here. We're going to talk about isotopes, and after isotopes, we're going to talk about covalent and ionic and hydrogen bonds. Isotopes are different forms of the same element. They have the same number of protons, but they have different number of neutrons. I tell my students, think of isotopes as twins or triplets because they're almost the same person, but they're not quite. They're actually different. So the most common isotopes that we talk about are C12, C13, and C14. Okay, remember that the atomic number of carbon is 6. So I'm just going to write it at the bottom because when we talk about isotopes, we usually find that the mass number is written at the top. So remember from earlier, the carbon has 6 protons, 6 neutrons, and 6 electrons. Actually, I'm going to remove the neutron part for now because the point of this slide is to show that isotopes, which are the different forms of the same element, will have the same number of protons but different number of neutrons. So let's go one by one. C12, which is the first one on our list, it has 6 protons, right? Because we see the atomic number right there. And it has 6 neutrons because we see the mass number right there is 12. C13 has 6 protons, but it has 7 neutrons. How do we know that? 13 minus 6 is 7. So it has 7 neutrons. Carbon 14 has 6 protons and it has 8 neutrons. Why? Because 14 minus 6 is 8. So nitrogen also has isotopes, but we are just going to focus on carbon right here. And this shows you that the different forms or different isotopes of the same element will have the same number of protons, but it'll have different number of neutrons. Let's talk about covalent bonding. So covalent bonds happen when electrons are shared between 2 elements. We're going to talk about methane here. Methane is a gas and its formula is CH4. Let's start drawing our carbon atom. So remember, carbon is 6 protons, 6 neutrons, and 6 electrons. And hydrogen is 1 proton, 1 neutron, Actually, this number is like 1.0 something. And then 1 electron. So we're going to draw carbon 6p, 6n. The first shell has 2 electrons. The second has 4. I should have drawn it a little bit lower. Now let's draw hydrogen. So hydrogen, 1 proton, 1 neutron, and then it has just 1 electron in one shell. What hydrogen wants is to have 2 electrons in its valence shell. And so we will have 4 hydrogens come and share their electron with carbon. So here we're going to have and then here I'm going to have to write over the writing. So in this way, I'm going to draw this one a little bit closer so it looks like it's sharing. So in this way, what we notice now is that all of our atoms are happy. Carbon is happy because it has 8 valence electrons, right? 1, 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen is happy because its valence shell also has 2 electrons, right? So 1, 2 for this hydrogen, 1, 2 for this one, 1, 2 for this one, and then 1, 2 for this one. So this is covalent bonding. It occurs when electrons are being shared between 2 atoms or 2 elements. Saying elements or atoms is pretty much interchangeable. Now we're going to talk about ionic bonding. Ionic bonding happens when 2 ions are strongly attracted to each other. Ions form when they either donate or gain an electron. When atoms gain or donate an electron, an ion is formed. We're going to talk about sodium here, and we're going to talk about chlorine here. So sodium has 1 valence electron. Okay, I'm not going to draw the rest of it just to save time, but sodium has 1 valence electron in the 3rd shell. Now let me redraw this. So this is the nucleus. It has protons and neutrons. For now, we're not going to talk about how many protons and neutrons, just to save time. First shell has 2. Second has 8. And then the 3rd shell has 1. Just 1. Chlorine, on the other hand, if you go to chlorine, chlorine has 17 electrons. And so here's the nucleus. 1, 2, 8 go here. And then 7 here. Okay, so chlorine has 7 valence electrons, and sodium has just 1 valence electron. What's going to happen is that sodium will say, let me just give chlorine 1 of my electrons. When I do that, my outermost shell will go away because I've lost that electron. I'm left with my second shell, and my second shell does have 8 valence electrons. So my octet will be complete. I will be happy. And chlorine ends up gaining an electron, which means now it has 8 valence electrons and it is happy. its shell is complete. When sodium gives away an electron, it gains a positive charge. Why? Because electrons carry a negative charge. So when you donate a negative charge, you end up with a positive charge. Chlorine, when chlorine gains an electron, it gains a positive charge. So now chlorine is negatively charged. So what you have essentially, you have a sodium ion and you have a chloride ion, negatively charged. And these two are attracted to each other, forming an ionic bond. So ionic bonds are basically very strong attractions that negatively charged ions have to each other. So when you have a block of table salt is simply NaCl, sodium chloride. If you zoom into it, right, if you take a chunk and you zoom into it, what you're gonna see is a bunch of sodium ions and chloride ions that are attracted to each other. So attracted to each other that they're holding on to each other. And that is what an ionic bond is. So how do we know if two elements will form covalent bonds or ionic bonds? There are two simple ways to know. The first one is that covalent bonds will form between nonmetals. And you can look at the periodic table to see where nonmetals are. Like I said, most of them will be labeled. If they're not labeled, you can just remember it. They're going to be towards the right of the periodic table. Ionic bonds will form between metals and nonmetals. Metals are on the left side of the periodic table. The second way to know is that covalent bonds will form if the electronegativity difference is less than 2.1. And if it is greater than 2.1, then an ionic bond will form. I talked about electronegativity in a different video and I'll link that here. But electronegativity has a number, and it basically means how strongly that particular atom pulls electrons closer to itself. And every element has its own electronegativity number. If you're looking at two atoms and trying to figure out which type of bonding they will have, you subtract their electronegativity number and see the difference. If it's less than 2.1, you have covalent bonds. And if it's more than 2.1, you will have an ionic bond. Lastly, we're going to talk about hydrogen bonds. And the most popular of hydrogen bonds, they occur in water. They also occur in our DNA. The two strands of our DNA are held together by hydrogen bonding. A hydrogen bond results when hydrogen is bonded to an electronegative atom like oxygen, nitrogen, or fluorine. Here we're looking at 3 molecules of water. So this is 1 molecule of water, 2nd molecule of water, and 3rd molecule of water. So when we look at one individual water molecule, the oxygen is bonded to the hydrogen through a covalent bond. In other words, they are sharing an electron pair. Both these bonds are sharing electron pairs. Oxygen is very electronegative. So that means it's going to pull the electrons closer to itself. Electrons are negatively charged. So when the oxygen starts to pull that negative charge closer to itself, it gains a slight negative charge. And hydrogen ends up with a slight positive charge. When you put a whole bunch of water molecules next to each other, you are putting a whole bunch of negative and positive charges closer to each other. So this hydrogen is positive slightly, this oxygen is negative, this hydrogen positive. And so again, the positive and negative charges are attracted to each other. And what happens is that a attractive force forms between one hydrogen of one water molecule and one oxygen of the other water molecule. This is called a hydrogen bond. In this example, the hydrogen bond is between hydrogen and oxygen. You will also see it forming between hydrogen and another molecule where the hydrogen is bonded to a nitrogen that has a slight negative charge, or fluorine that has a slight negative charge.